part 2 of this wonderful video. At the end there, it started freezing up on me. I thought I lost it all. I didn't lose it all. So we're going to finish up the last couple examples here, and we'll call it a day. So I apologize for the 2 parts, but, you know, sometimes technology fails us. All right. So algebraically, adding, subtracting vectors. I think a lot of you might enjoy this method a little bit more than the graphical approach, but who knows. So with these, we're just adding our x and our y components, or our I and j components together. So if I write this one out, 6, negative 2 plus, and then since w is 2 and 5, we got that guy next. And now I'm just going to add the 6 and 2 together to get 8. Negative 2 and 5 together to get 3. Pretty darn straightforward. I don't like how that was. There we go. This is a little more even. Pretty darn straightforward, right? Nothing crazy. For the next one, we got to make sure that we subtract, okay? So we got to distribute that negative through. So we'll have 6, negative 2 again, minus, and then 2, 5. So 6 minus 2 is 3. Negative 2 minus 5 is negative 7. Awesome. Fantastic. Wonderful. So that's it for those. Now find a scalar multiple and a magnitude of a vector. So we have that scalar from, we have the 5 here. And it's basically like, think of it as like just distributing through. That's how it's going to mathematically work out there. So what we'd have here is 5 times 6, negative 2. So I'd have 30, negative 10. Cool. You can also be writing these as 30i minus 10j. You do a little hat. Whee! That's fun. Isn't that fun? So fun. All right. Next one. So we have, little combo action. We have the scalar multiple and subtraction. My goodness. Okay. So I have 3, 6, negative 2. And then minus 2, and then we have 2, 5. Now, the way I'm going to deal with this is, instead of 18 and then negative 6, and then I'm going to go with addition here and distribute this into be negative 4, negative 10. Okay? And I've already taken care of the negative. That's why it's now addition there, right? And then I would add those. I'll get 14 and negative 16. Dunzo. Cool. I like it. And again, you could write that as 14 I hat minus 16 j hat. Little hat. All right. Last one for this. And then we're going to do a unit vector, as you can see. Magnitude. So we're doing magnitude of v. So that would just be my x direction squared plus my y direction squared in the square root. It's basically Pythagorean theorem. So we have our distance formula. 6 squared plus, and I can write negative 2 in parentheses squared, or just, I know it's going to become positive. So I have 36 plus 4. That gives me 40. And when I break that down, that's 4 and 10. So that'd be 2 root 10. So I was running out of room there for my magnitude. Lovely. All right. Again, you could write negative 2 and put it in parentheses, but knowing that it's going to be positive 4, that's really what matters. Okay? All right. So a unit vector, all right? A unit vector has a magnitude of 1. Okay? That is a magnitude of 1. Lovely. So I like this comparison here. Just like a unit price at the grocery store, found by taking the price of an item and dividing it by the number of units that it contains, a unit vector can be found in the same fashion. We take the vector and we divide it by its magnitude, its length there, right? So kind of like a similar, like, what is it for 1? Okay? For 1 apple, right? Or 1 box of Kleenex. We were doing that the other day at the Costco. We're members, and we were purchasing a thing of Kleenex. We're like, well, which one's the better deal here? We went down to sheets, all right? We went down to sheets. We did the math. Math in the wild. I pulled out my TA84 in the middle of Costco. I'm kidding. I just pulled out my phone. All right. So if we want to find our unit vector, I would take the vector and divide it by its magnitude. Beautiful. Beautiful. Another way of looking at this one, So you could solve for v if you wanted, and you would have u times magnitude of v. Alrighty, or you could write that as, I guess since this will just be a number, perhaps you write it like that. It'll be a nice little coefficient with a vector afterwards, right? A number times a vector, a scalar. Alrighty, I like that, scalar. That's the right vocab word to use here, Mr. Allen. Okay, so find a unit vector for this one. So find a unit vector in the same direction, one direction. Harry Styles. Back to the problem. As 12i hat minus 5j hat. How can you confirm that your answer is correct? Show this wonderful work. Okay, so we want to find the unit vector. So we have the vector. But remember, we're going to take that vector, we're going to divide it by its magnitude. So it looks like we have to find our magnitude of this one, right? Now, you may notice that, well, we'll do the Pythagorean theorem. We got 12 squared, 5 squared, or negative 5 squared. Same thing. That's going to be 144 plus 25. So it's the square root of 169. And that gives me 13. So my magnitude is 13. You may have also noticed that, 12, 5, this is a 5, 12, 13 triangle. Those triples do come up even in this vectors unit. So if you know your triples, you're in good shape. Okay, that's going to save you a little bit of time. Time is money. That ain't funny. All right. So I would have now my unit vector is going to be, sorry, got interrupted there. We got the, in the common space, you know. So the unit vector is going to be our vector of 12 I hat minus 5 j hat over my magnitude, which is 13. All right. So when I divide this out, fractions, right? So my unit vector is just, I'm going to break it apart. I'm looking very concentrated and writing my fractions. There we go. 12 over 13 I hat minus 5 over 13 j hat. That is the unit vector, a length of 1. Now, how can we confirm that our answer is correct? Because that's what it asks us, right? How do we confirm that? Well, to be a unit vector, that means I have a length of 1. So, or a magnitude, excuse me, of 1. So if I do my magnitude of this unit vector, I would have 12 over 13 squared plus 5 over 13 squared, or negative 5 over 13 squared. It's going to be the same thing. That would give me 144 over 169 plus 25 over 169 on the square root. And now that gives me 169 over 169, which is the square root of 1, which is just 1. Boom. Check. Done. Magnitude of 1. It's a unit vector. Woo. Woo. Good stuff. That's it. Thank you guys for hanging out for part 2 here. Apologize for the 2 different videos. Tech issues. It happens. You guys keep it real, keep it fresh. Always remember to do your best. And yo, bro, you only round once. River Dog Jenny on the gram, America, Costco. I can't stop. I'm going to stop.